Welcome to Hyperscale Data Center Mega SOP Part 3. On-time delivery, OSHA compliance, life safety, workforce sustainability, and fiber copper quality. Project: Hyperscale Data Center Operations. Applies to TPMs, LVVs, GCs, subcontractors, consultants, QA and QC teams, facility management, client representatives, and validation teams, and network deployment teams. By José-Alonso Hurtado González. Objective: complete projects safely and on schedule by prioritizing OSHA compliance, protecting human life, ensuring quality, and maintaining reliable fiber and copper infrastructure. 17. Telecommunications standards compliance. All fiber, copper, and other infrastructure must comply with recognized telecommunications standards, including 1. BICSI installation methods. 2. TIA 568 cabling specifications. 3. ISO, IEC. Structured cabling regulations. Compliance violations requiring urgent rectification include 1. Bend radius infractions. 2. Improper cable dressing. 3. Inconsistent cable management. 4. Unmonitored connector handling. 5. Incomplete label verification. Adhering to standards is essential for reliability, maintainability, and successful validation. 18. Operational blockers and contributing factors. The following factors elevate the risk of failure and require vigilant monitoring. May vary. High turnover, rushed deployment, inadequate QA, insufficient training, poor supervision, heat, weak handoffs, post-test modifications, and poor subcontractor coordination increase project risk, reduce quality, and threaten schedules. These risks require proactive management and never justify project failure. 19. Failure response and recovery procedure. Upon encountering a validation failure, the following action should be enacted. 19.1. Immediate actions. Stop repeated attempts, preserve field conditions, notify TPM, QA, and QC, and applicable leads, and determine whether the issue involves safety, physical conditions, environmental factors, or hardware. 19.2. Troubleshooting review. Verify connector cleanliness, placement, labeling, routing, bend radius compliance, splice and patch quality, hardware optics condition, cooling status, firmware, software, and any post-validation changes. 19.3. Documentation record. Document failure tickets, OTDR or OLTS results, inspection outcomes, connector images when possible, rack and row specifics, accountable vendor, rework completed, and final resolutions. 19.4. Revalidation. Revalidation shall only occur after the suspected cause has been documented and corrected. If the issue persists following revalidation multiple times, a formal root cause analysis, RCA, may be initiated. 20. Preventive actions and process improvements. 20.1. Mandatory preventive measures. Inspect connectors before pairing. Uphold mandatory cleaning protocols. Perform QA verification for splicing. Cross-check labels with drawings. Conduct installation audits. Perform QA inspections at crucial points. Provide ongoing technician training. Maintain heightened oversight of vendors. And enhance coordination between installation and validation teams. 1.2. Recommended equipment. Utilize fiber inspection microscopes, professional cleaning kits, OTDR equipment, OLTS testing tools, visual fault locators, VFL, proper labeling implements, and approved fiber test kits. 20.3. Long-term program improvements. Implement structured fiber installation training programs, standardized validation methodologies, improved quality evaluations of vendors, monitoring patterns for repeat failures, and better integration of safety, QA and QC, and delivery planning. 21. Communication protocol and e-handoff requirements. 21.1. Real-time reporting. Any significant changes influencing as applicable safety, schedule, quality, validation, energization, cooling, staffing, hydration, or fatigue must be communicated without delay using designated channels. 21.2 handoff. Minimum requirements. Every handoff must include: communicate completed work, outstanding tasks, current obstacles, safety considerations, QA and QC assessments, validation failures, ongoing rework, hydration or fatigue challenges, staffing deficits, and priorities organized by row, pod, or rack. Effective handoff quality is crucial in mitigating repeat errors and preventing time loss across shifts. 22. Performance metrics. 22.1 Schedule metrics. Track energization and validation progress, reburning rate completion, milestone performance, and failure recovery times. 22.2 Safety metrics. Verify zero reported incidents, compliance with PPE protocols, adherence to OSHA training, hydration requirements, fatigue control measures, and rest day regulations. 22.3 Quality metrics. Monitor the rate of validation failures, ratio of connector contamination, incidence of splicing defects, frequency of labeling errors, rate of reburns, and trend rate of recurring failures. 22.4 Workforce sustainability metrics. Monitor weekly worker hours, compliance with rest day policies, frequency of overtime exceptions, effectiveness of staffing balance, and leaders' adherence to ethical scheduling standards. 23. Enforcement. Immediate removal from duty, escalation, or corrective measures will follow in response to: promptly report safety breaches, unauthorized work, untrained site access, improper fiber handling, connector contamination, non-compliance with approved sequences, coordination failures, hydration or heat stress hazards, unsafe scheduling, excessive fatigue, and validation work, lacking QA and QC oversight. 24. Final operating principle. Coordination enhances progress. Discipline ensures safety. Quality minimizes rework. Protecting human life is the ultimate obligation. When? Ensure stakeholders maintain continuous communication. Leaders drive coordination. Work follows established sequences. Teams receive proper training. Fiber and copper are managed correctly. Connector cleanliness is verified. Splicing is validated. Hydration is maintained. Fatigue is actively monitored. Work hours are managed responsibly, and personnel receive adequate recovery time. Then, this approach increases the likelihood that deadlines are met, human life is protected, validation failures are reduced, quality is improved, rack deployment remains reliable, and workforce performance is sustained. We've reached the end of Part 3 of the Hyperscale Data Center Mega SOP. I sincerely hope this presentation has provided valuable insights and a deeper understanding of the standards, processes, and best practices that drive safe, efficient, and successful hyperscale data center operations. Thank you for investing your time in these video series. Your commitment to safety, quality, teamwork, and continuous learning helps build stronger projects and a more reliable critical infrastructure. Thank you for watching. If you found this presentation informative and valuable, please support the channel by subscribing, giving this video a like, and sharing it with colleagues and others in the industry. For additional information, contact José-Alonso Hurtado González.